This lesson is for Advanced Algebra, Lesson 3.5 on best fit lines. Students need to be careful of the fact that a best fit line can have multiple names. The line of best fit or the best fit line, those are kind of interchangeable. And then in the lesson they do talk about a least squares line, and we'll talk a little bit about that at the end of the video. The regression line or linear regression is what the calculator uses to find the best fit lines. Those are the commands that students are going to want to look for when they're finding a best fit line on the calculator itself. Keep in mind that what we're finding here when we do a best fit line is a linear model or a linear equation. So those are all basically referencing the same thing. When you're doing linear regression on the TI Inspire calculator, you will type in your data into a new list or spreadsheet page. It's important for students to start a brand new document, not just a new tab. The calculator will function better if you're starting from a brand new list. It's also helpful if you don't have other documents open and other spreadsheets that are open at the time that you're making your regression attempt. Once your new spreadsheet page is opened up, go ahead and type in your data, and we're going to start with some data here from Activity 1 in the book. So they give you this little teeny tiny table, and know that basically unless they tell you otherwise, the first column is your X and your second column is your Y. When you type it into your spreadsheet, you're going to want the X's to be in column A and your Y's to be in column B. You don't need to worry about any labels or highlighting any variables here. You just simply need to type in the numbers. After that, you're going to highlight both columns, and you'll have to use your Shift key to do it, and I'll show you that or demonstrate that shortly. Then you're just going to choose these commands on your calculator: menu, statistics, stat calculations, and linear regression. So let's go ahead and give that a try. When you choose your new spreadsheet, you'll type in the numbers. It's very important that you type in the numbers and hit enter each time. Students who use the arrow keys tend to end up with more error messages during this process. So it's better for you to hit the number and then enter each time. Especially important is when you hit this last number. When you type it in, make sure you hit enter when you're done. A lot of times students just hit 235 and they don't hit enter, and the calculator then doesn't register that last number as being in existence. Once you've got all your data into the spreadsheet, use your arrow keys to continue to go up until one of the columns is highlighted. Using your Shift key, which on the black calculator is above the 7, on the gray calculator it's an upwards arrow right underneath the Control button. So on the gray calculator, go right under Control, you'll see an up arrow key, that's your Shift key. So hit the Shift key and then go right or left to highlight two columns at a time. If you're unable to highlight the two columns at a time, look up here in the corner and see if it says all caps. If you are in all caps, then you need to do Control Shift to get rid of that. Once the two columns are highlighted, then you do menu, statistics, stat calculations, and then you choose linear regression. Keep in mind that there are two linear regressions available. Typically I have students choose the first one because that's mx plus b, which is what they're used to. You'll get a pop-up window here which I would like you to take one moment to look at. Make sure that the linear regression is the one that you wanted, and make sure that your x's were indeed in column A and your y's were indeed in column B. That's because we highlighted those in advance so that we don't need to type anything here. There may be an instance where you'll want to flip-flop your X and your Y columns, and so this would be the place you could do that. And you could type in B here and A there, and it would reverse the table. Use your Tab key to go all the way down to OK, and you'll see that it adds some stuff to your spreadsheet. You'll see that it gives you your equation all over again, mx plus b, and it provides you with a value for m and a value for b. So let's just round those numbers off and write our equation. So we ended up with about 20 for x, 20 for m, and about -2 for b. So you could say -2 there or plus -2. So there's our model, our equation, our best fit line, our regression line, our least squares line, all of the above. So I want students to try this again for Activity 2, which is on page 177. This is a much longer process because there's more data for them to type in. If they're not sure, typically you can assume that the X row is your independent variable and your bottom row is your dependent variable. You can also tell that on this one just from logic. This is information about time spent underwater for a scuba diver. So if a scuba diver spends time at a maximum depth of 60 feet, they will need more and more time to decompress. So the amount of time they spend under the water determines how much decompression time they will need. So indeed, this is the independent and that's the dependent. So again, this would be column A and this would be column B. Again, you don't need to worry about any labeling here. It's just a matter of reorganizing the information so that it flows well into the spreadsheet. So students can go ahead and try that again on their own, type in all the data, highlight the data, and then choose linear regression. Students can then check and see if they got the same answer as what I got over here on the screen. Students may also be asked to do some follow-up questions like question number 4. If a diver spent 130 minutes at a maximum depth of 60 feet, estimate his decompression time using the regression line. So we need to write what we got for our regression line. So it looks like we got about 0.48 for the M and about negative 29.9 for the B. So we would use that formula now and one of these two numbers, and we just got to read carefully to figure out which number we're going to plug in. Keep in mind that the depth of 60 feet is what this is a table of, so we don't need that number. It's this number that we're looking for. It is minutes, and both pieces in the table represent minutes. We got to figure out which one they mean. He spends 130 minutes at 60, so that means this value is an X. So we're going to plug in 130, and we're going to see what the model generates. So we're going to get an answer for that. And so I got 32.5, and so that would be minutes. And 130 would be about right here in our table, and so we got a value that's in between the Y values, so that answer makes sense. Keep in mind that your model may not actually match the data completely. Keep in mind that a best fit line isn't always going to be perfectly lined up. It's going to fit it the best, but it's not going to be perfectly fitting it. So there is an amount that it may deviate from what it should be. So for example, if we take the number 120 and plug that into our model, we're expecting it to generate the number 27 because that's the data that we have in place. If you go ahead and calculate this, you actually end up with 27.7. So the deviation is the difference between what it should have said and what it actually gives. So the difference there is about 0.7. The deviation is 0.7 of what the model generates versus what it should be.